Hello guys, in today's video I'm going to be refactoring some of the code that we wrote in the 2D and 3D space movement video. Um, I, I want to make sure that we're actually using the physics engine that Unity provides us to actually do these things, because some of the things that we were doing was just cobbled together, and of course it works, but we can get a better system for our simulations if we just use the physics engine that Unity gives us. So the first thing we just do is click on the player and add a rigid body. So it's essentially a component that allows us to be able to access the physics engine on this capsule object that we've created. If you remember from the previous, from that first video, that we have a capsule object and inside the player object. So that's this capsule that we are seeing. So from what I've experimented, I just changed the mass to 3 and then I don't use gravity. So that's all. And then in the player script, which is the one that has to be actually refactored. So I already have it open. If you don't have it open, you can just press open and open it in Visual Studio. So very quickly, I mean, all this works, but we can just comment it out because like this is not technically using the physics engine. So comment this out. So that's Control C. Okay, seems like my cursor is playing with me. Okay, yeah. So what we have to do now, so yeah, I want a serialized field so as to be able to access a field that's even private within the Unity editor. So I want a move speed, the speed at which the capsule is going to be moving at. I'll just make that 3F is what I've experimented with. And then I want a private rigid body RB. Yeah, then I want a void start. Yeah, so yeah, I have code completion. It's just bringing everything for me. And then, so basically what we're doing in this function is that we're getting the component of the rigid body. So it's important because if we don't get the component, there's no way we're actually going to be able to use it. And then the last function is private void fixed update. Yeah, so in this function, I'm first going to get the axis. So I'll get the horizontal axis. Horizontal equals input dot get axis, and then so input the get axis horizontal, then float vertical equals input dot get axis, and then vertical. Yeah, so we just put in the axis name. Okay, so the mistake, I made a mistake here. This should actually be H and this should be capital V. So the axis name. Then after this, what I'm going to do is that I'm going to create a new vector actually. So I'm going to have a vector 3 and I'm going to name it move dir, just for move direction. That's going to be vector 3. Just so it has to have a new keyword in front of it, new vector 3, and then I'm going to assign the horizontal to this, and then for these y axis, it's just like in that video where we made the y, because we didn't want to move along the vertical direction technically, so we're just moving along the x and z, and then we just assign the vertical to the z axis. So we have our vector 3, which is our move vector. So it just points us in the direction that we're going to be moving. So to actually move it, we're just going to be using add force, the add force function. And then so we're just going to use move dir, which will tell us the direction to move in, times the move speed. So with this, we should have everything we need to make this work perfectly. So if you go back into the Unity editor now, okay, so now that we're back in the Unity editor, I guess it's now it's time for us to actually test if everything that, because an important part of refactoring is testing if what you wrote actually works. I mean, and we do it incrementally, but because like the amount of code that we had to replace was not so much, so we didn't have to do like a long test. So So now we can press W and we can see that it's moving in the proper directions, and it has some kind of delay, which is some of the things that have been imputed into it automatically by the physics engine. So we can move it. You can use WASD, WASD, you can use the arrow keys, even if this were um say for instance, of course, one part is that it continues moving. I've not completely figured that out yet. Uh, you could use like a joystick, you could use like a gamepad, so it makes it really easy. Of course, Unity actually has a new input system that is different from the one that we use now, but this still works perfectly for us. So if you go back, so we just that's essentially it. So this is all we have, and the code is working. So we can just remove all these jargons, and then this will make our work much more easier, so that when we actually make our collisions video, everything works perfectly, everything works in sync with what we're actually about to do with the Unity physics engine, making our simulations, our math simulations, our physics simulations, so that they are not out of sync. So this just works perfectly. So I follow some of the design advice that my friend who works at Unity gave me, and this works pretty good now. That's the refactoring. So thank you very much for watching. This this video on refactoring my code to work with the physics engine. There are other videos suggestions up here for new videos that I've created and some videos that I've made in the past. Make sure to click and watch. Thank you very much for watching.